Greetings everyone, myself Kartikay UNIYAL, a third year EPS student in IIT Roorkee, and today I will be presenting the lab work I did for the course Microprocessors and Microcontrollers PSC 306. And as you can see from the title, I will be presenting about the LED matrix interface using the ET-MAT module. So let's get into it. So here is the outline of everything that we are gonna cover for this presentation, starting from the basic principles of the LED matrix, then the ET-MAT hardware layout, the mnemonics of the assembly code which we are using to interface this LED matrix, the basic code for displaying easy digits, the timing and the delay logic, as well as an exercise which I did for this course. So let's start with the LED matrix fundamentals, and as you can see here we have 64 LEDs, and these 64 LEDs are controlled using just 16 input output lines, that is just 16 wires. So how we are doing that is that we have 8 wires connecting 8 wires going through the 8 rows and 8 more wires going through the columns, and the point of contact, and not exactly the point of contact but visually the point where all the you can see the point of intersection will be, where there is a point of intersection, that's where we put an LED. So that's how we get 64 LEDs controlled by just 16 lines, and the 8 wires of the rows acts as the anode, while the 8 wires of the columns act as the cathode. And my LED, how I control LED is when for a particular LED the row which controls is high, as well as the column is low, that is no voltage there, then that particular LEDs brightens up. Okay, so let's go through the ET-MAT hardware layout. The ET-MAT here stands for the Electronic Trainings Matrix Module, which is the matrix circuit in which our LEDs are connected. So this ET-MAT is connected to our 8085 microprocessor through 8255 peripheral interface using a 6026 pin FRC cable. This cable is used to send the data from send the output from our 8085 into the module and then to the LED, so that we can see what's happening. How it works is that our 8255 has 3 ports, port A, port B, port C. Here the port A controls the 8 rows, port B controls the 8 columns, and the port C is the mode configuration for my register. So using port A we are setting the logic for our 8 rows, using port B we set the logic for our 8 columns. And the control word here is the ATH, that is we are selecting all ports, each port A, port B have 8 output wires, so we select them all as the output port. However, and why do we use ATH for that, I will get into it. Okay, so let's start with initializing it. So the first command is MVIA ATH. MVI stands for the move immediate, that is we immediately move to the register A, which is also port A, and we are moving it with the data ATH. The ATH is we are not loading it from anywhere, we are giving it the memory directly. And then we have out 03H. The out, what it does is it takes the output which is generated by our 8085 and it takes it and it passes it into the module. This line is what sets that up. So MVIA starts the input processing and the out 03H, it starts the output. We are setting the input output ports for now just. And also why we are using 30H for this. So why we are using not 30H, why we are using 80H for it. How 80H works is that if you write 80H in the hexadecimal, you get 1 followed by 7 zeros. So what's happening here is that since the first bit is 7, it activates the mode set function, which selects the mode of the input output, and after that every single value is 0, which essentially configures every port to be an output port. So let's talk about the next part, which is the outer loop. So this outer loop defines that where are my characters which are going to display. So for now we have chosen 3 characters, which are A, B and C, and how it works is that MVID, which is move immediate MVID, which is the move immediate D, it loads the value. In D we are loading the value 03. It tells that there are 3 total number of characters to display, each characters being the 8-bit character, 8 byte. Then the LXIH, which is the load extended immediate, tells the address of where those characters are present, and the characters to be displayed are the data for the character to be displayed is present starting from 2050H. Then we have DCRD. Now DCRD is decrement D, which is it decreases this value, and why we are doing is that once one character is displayed, we decrease it, then display the next character, then decrease it, and when it and next character is the loop back, which essentially loops this thing continuously, infinitely. Okay, let's talk about the inner scan loop. This is essentially the main program which is making the LED matrix work. So what happens in this is that the register B holds a column mask. We start B, which is equal to FEH, which is in binary 7 ones then a 0. What it means is that only the right mode bit is 0. So for using my LED interface, what I need is the rows to be 1 and my columns to be zeros. So when I input 7 ones and only 1 0, which means only one of my columns is going to brighten up. So when my value is FEH, only one of my column will brighten up, and all other columns have logic 1, so they are inactive. Now RLC here is for rotate left through carry. It shifts the every bit by 1 position to left, and the bit that falls to the left comes back to the right. So the initial value, which is FEH, which was earlier all ones and just a 0 in the end, it now becomes 6 ones, a 0 and a 1 now, which is FDH. So the 0 has moved once, and now instead of column 0, which was earlier activated, the next column will now be activated. So it's looping back through all the columns. So the reason why we need to do this is that the output of my 8085 microprocessor is only gonna be an 8-bit output. So at a time, so I cannot control all of my 64 LEDs at the same time. So how we do it is that at one time only one of my column is active, and then it shifts to the next column, to the next column, to the next column, and this loop continues at a very fast pace. And then you may ask that how am I exactly able to see it visually? Like if I do the experiment, you can see all the columns, whatever data you have, all 64 to be responding simultaneously. That's because of the speed at which this is being carried out. I will get into that soon as well, but first let's understand this part as well. So yeah, we are doing this. We are doing rotate mask left, which is rotating the value so that the next column can activate after that. So now let's talk about the delays which we are introduced into it. So they are total 4 nested counters, and these counters are like some timer which determines the delay which is gonna be there in my operation. So how it's happening is that the innermost counter is gonna be the register A, of course, which is loading the value. In register A, I load a value which is, here it is 40H. For before that, let me explain what is code. This code essentially tells for how long I gonna display each character. So let's as I told, we are gonna display a total of 3 characters. So there should be like for how long I'm gonna display one character, then gonna change it to the other character. This is the loop that is gonna define that. So yeah, in the register A, I first load a value which is essentially the time for which I wanna display each character, and then I start the loop. And this what it loop does is that it decreases the value of A which is loaded into A, and once the value which is loaded into A reaches 0, the other character is gonna be displayed. And yeah, as you can see, the J and Z function here, what it does is that it jumps back if it's not 0. So what happens if it's 0, the value in the A, if it becomes 0, it will not jump and it will display the next character. For the next character, same thing will happen. It will loop back again. Now value will be loaded to A, and then for the same time the next character will be displayed as well. Okay. Yes, so here is the complete execution flow, how exactly it all happens. So as you can see, we start by selecting the input and output ports. We define the input, we define the output, we initialize the peripheral interface. Then we define the loop which is gonna show how many characters we are gonna display. So here the loop, which is the loop 4, and here see D is equal to 03, which tells that there are total 3 characters which are going to display, and this HL value is 2050, which is telling where exactly that the characters which I want to display, their data of the character, individual character, is stored. Okay, and next is loop 3, which essentially is loop 3, which what it does is that it rotates through the column. So like it activates one column, because that's how the LED matrix works. Only one column is activated at a time. We can only activate one column at a time, and we loop through all of them turning on one column at a time at a very fast pace. Then we have loop 5, which is the delay loop, which decides how long each individual character is gonna be displayed. And there is the loop 1, where the actual display is happening. So it takes the value from the address and displays it in the individual column. So the column in which is being displayed, it loads the address, loads the data from the address into that column. and then we go back to the loop 2, which is essentially loop 3, that is the next column, and then we do the same thing. In the next column I load the next data value for the same character, and we repeat that until one character is complete. Once the first character is complete, I load the next character. For the next character, the first column is activated. For the first column, the data is called, and it's it loops over that data until the delay, which is for how long the character is displayed, is completed. And once it is done, just like that, all 3 characters are being displayed in an infinite loop. So if we work it out properly, the code and everything, this is what we are gonna see in our 8x8 matrix. We are gonna see that this the rows and columns are gonna be light up in this way, and right here is the data which is being data for each column. So F8 is the data for lighten up only these 5 LEDs out of these 8 LEDs in this column. Similarly, 1-4 is the data to light up these 2 out of these 8 columns, and so on. As for how it is being calculated, how this data for each column is calculated, is that first of all, it is an 8-bit data. So you calculate it by dividing it into half here, and then you take these values and convert it into hex. So it's like 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, and 2 raised to the power 3. So if all 4 are activated, it will be 1 plus 2 plus 4 plus 8, which is 15, which will give me F. So it is an F here, and here it is, and I do the same thing for up here. So it's 1, 2, 4, 8, and here only 8 is active, so here 8. Similarly, let's say this column, so with our dividing line here, I can see that this is 2 raised to the power 0, which is 1. So there it is 1, and here it is 2 raised to the power 1, which is 2. So it is 2 here. And so as you can see, so this whole column is active. So I divide, this is whole active, which is 15 F in hexadecimal, so F. Similarly, this is also completely activated, so this is also an F. So I get an FF. Nothing is activated. I am getting in this row, nothing is active. All of the LEDs are dim, so I get a 0 for this part, 0 for this part, and then overall 0 here. So this is how it's done. Now this is how the data for individual characters, data for the individual row of an individual character is decided. Okay, let's talk about the timing. So as I said earlier, what's happening is that instead of all LEDs being lit up at once, what happens is that first only this column is lit up and all these are dim. Then this is dim and this is lit up. Then this is dim, this is lit up, and every other is dim. Then this is lit up, every other is dim. This is lit up, every other is dim, and that's how it continues. But if you do the experiment, you will not be able to observe anything similar. You will see that it's being printed properly. Why that happens is because, you see, even though we are outputting, or we are only 8 bit of data, which is only one column, the 8085 microprocessor can work at a refresh rate of around 3.72 megahertz, which is its internal processing speed for per cycle. So after all these processes, you can see I have done some calculations, and you can see that out of all these processes, its refresh rate is going to be 3.25 kilohertz. That means in 1 second it can do this operation of turning on one column, then turning it off and turning on another column. It can do this operation around 3250 times. So even though each column is being activated at once and then being dimmed, it happens so fast that to our eyes it seems that it's a continuous movement. We see all of the 8 rows, all of the 8 columns being lit up or dim at the same time based on the data which we have given them. So let's talk about the small exercise that I did for this experiment, and what I did was I tried to print the 4 patterns on the playing card, which is the club, the hearts, the spade and the diamonds. So it was a very interesting exercise, and we calculated the data for each of these pattern myself, which have shown here the data for the club, the heart, the spade and the diamonds. How exactly is the data calculated is, I think we have known here how exactly we calculate this data. One small change in the code that we have to make to print all of them is that in our first do we need to change from 3 characters to the 4 character, which is MVID 04 instead of initial 03. If I go back and show it, instead of initial 03 I change it to 04 in order to emphasize that there are now 4 characters which I am going to print. Okay, so now that I've covered the basics of everything that I've done, let's me show you how exactly it will look like when we do it. So now I am executing the code. For execution the command is G2000. 2000 is the part where my code begins from, and okay, the G and then the 2000, and when I execute it you see that all the patterns, like you can see this pattern which is similar to the pattern I shown, and you may pause and try to check all patterns. All the patterns are very similar. So you see that's how an LED matrix interfaces work. That's how we load the data. That's how we decide on how many loops we need, what refresh rate, how to decide how long each character is displayed. And with that I thank you for your attention for this. Thank you for even seeing this presentation. Thank you.